Okay, so today is about acceleration due to gravity. So, so the term is well understood and well defined. So, in this case, we are going to learn about gravity acceleration. Acceleration means change in velocity. And what is the cause of change in velocity? Change in velocity is caused by the Earth's gravity. It means this acceleration is produced by gravity. This change in velocity is caused by the Earth's gravity. So, how do we represent this? The symbol to represent this is small g, and it has a fixed value. Normally, it is 9.81 meter per second square, but like at your level, we call it as we directly put 10 meter per second square. So, so the value it is represented by g, and its value is 9.88, which we normally consider as 10 at your level. There is no need to put 9.81. But if there is an MCQ and you have the option of 9.81, then you must circle 9.81. Otherwise, in numerical problems, we consider for simplicity as 10. Okay, suppose. Okay, how do we suppose? Uh, like suppose this is a ball, and like like the first time it was observed by Galileo observed with lot of experiment when he was exiled from city, and he was living in Pisa Tower. He observed in 1700s. In 17th century, he observed that whether you put this object, or this object, like this is their starting point, if they are released at the same time, suppose when these objects will hit the ground, suppose this is the ground surface, when these objects will hit the ground, that they will exactly hit the ground at the same time. There wouldn't be any time difference. There would be no time difference. So whenever we are normally thinking about this process, we considered that we believe that the larger the mass, the large object will reach first, this one will reach later, second is less heavier than this one, so it will reach later, and this one will reach at the end. But Galileo observed that when the objects are released and they fall from a certain height, they are independent of mass. Their mass has no influence, like they are independent of mass, and they will strike the earth's surface at the same time. Suppose initially these particles, when this particle was at rest, suppose this object was initially at rest, when you released it, it's like when it was in rest, its speed or velocity would be 0. When it starts moving, in downward direction, its speed or velocity increases with time. So when there is an increase in speed or velocity, that is called acceleration. Suppose it was in state of rest. When it would strike this surface of the earth, its velocity would not be zero. So it means by comparing the starting point and the final point, there is a change in velocity. Change in velocity is called acceleration. Suppose here is a 0 velocity, here is 10 velocity, so change in velocity is called acceleration. And during this period, the acceleration was produced, and this acceleration is called gravitational acceleration. Okay, so its value is fixed. What does it means? It's a kind of uniform acceleration. So let's assume few examples. Suppose the object is here and its velocity is 0. Okay, so this 10 means, what does this 10 means? This 10 means that the change in velocity is 10 meter per second square. Means with every second there would be an increase in velocity. There would be an increase in velocity, and how much it would be? It would be 10. So when this ball will fall from here to here, suppose it reached here, and the time taken would be in between these two intervals. Suppose the time taken is from here to here, suppose this is the distance which is traveled by the ball in 1 second. So time is 1 second, and how much distance is traveled? The distance traveled would be 10 meters. Okay, now it's like the velocity of this ball at this point would be 10, because there is a change, the change in velocity is 10. Okay, now you can see its velocity is 10. It means it can travel more distance in next 1 second. Suppose it will travel from here to here, and this time its velocity initially was 10. Maybe after 1 second there is an increase of 10 in it, and it would be 20 meter per second. So after 1 second its velocity would be 10, from 10 to 20. There is an increase in velocity of 10. So now with any two intervals, suppose you want to calculate the acceleration of these 2 points. For these 2 points, you are going to calculate the acceleration for these 2 points. For these 2 points, acceleration is like v minus u divided by t, and v is 20 minus 10 divided by 1 second, so it's 10. So you can see the acceleration found is 10 meter per second, but actually this is not the acceleration on the earth's surface, it is in air. So we cannot write it with small a, but we will write it like small g. Okay, now if the object is moving on earth's surface, its change in velocity is called acceleration, and that would be like a would be the representation of that acceleration. If the object is moving in upward direction and are going in downward direction in air, then at that time its acceleration would be considered as gravitational acceleration, and we will represent that acceleration by small g, and its value is 10 meter per second square. Okay, suppose the ball is here. Okay,